So, MiniMax just released MiniMax H3. It's their new open-weight video generation model. And in this video, I'll show you how you can run MiniMax H3 locally on a Google Cloud GPU. But you can use any cloud GPU provider you want. Just choose whichever is easy and cheap for you. Most of the steps should remain the same across different providers. First, let's create a virtual machine. I'll name it MiniMax H3 Demo, and then I'll select the NVIDIA L4 as the GPU. I'll keep the RAM at 16 GB, use the standard provisioning model, and change the region to Asia South 1. You can choose whichever region is closest to you. For the OS, I'll select Ubuntu, and this is important. Instead of using the latest version, I'll choose Ubuntu 22.04, since newer versions may cause compatibility issues. And for the boot disk, I'll set the size to 150 GB, turn off backups, and allow HTTP and HTTPS traffic. Everything looks good. It shows an estimated cost of around $0.76 per hour. So I'll click Create and wait for the VM to be created. So the VM is created. Let's access it using SSH. I'll click SSH, authorize the connection, and now we're successfully connected to the VM. Now let's run a couple of update commands to make sure the system packages are up to date. And then let's install the dependencies we'll need for WAN2GP, including Git, FFmpeg, Python, and a few required system libraries. And then we need to install the NVIDIA drivers. First, we'll check which driver is recommended for our GPU, and then install that specific driver. So I'll run this command to install the recommended NVIDIA 595 Open driver for the GPU. And then we need to reboot the VM for the driver changes to take effect. I'll reboot it manually. Now let's check if the NVIDIA driver is installed correctly. As you can see, the L4 GPU is detected successfully, so we're good to go. Now let's clone WAN2GP from GitHub and move into its directory so we can start setting it up. And then we need to create a Python virtual environment for WAN2GP and activate it. After that, we need to update pip and the other Python packaging tools before installing the remaining dependencies. And then we'll install the PyTorch library with the specific version we need for WAN2GP compatibility. And then we'll install Xformers, which helps optimize memory usage and performance during generation. After that, we'll install the remaining WAN2GP Python requirements from its requirements file. And then we'll fix the matplotlib backend so WAN2GP can run properly in the headless VM environment. And finally, we'll run WAN2GP. I'll also add the /share flag so it gives us a public URL to access the interface. Just keep in mind that you shouldn't share this link publicly, since anyone with the link may be able to access your WAN2GP interface. So here's the link. Let's open it in a new tab and access the WAN2GP interface. As you can see, it's working perfectly. Now, inside the interface, I'll select MiniMax H3. Since we're using an L4 GPU, I'll choose the FL2VA 20B pruned version. I'll keep the prompt as it is, set the quality to 480p, keep the aspect ratio at 16:9, and reduce the inference steps to 1. Then I'll press Generate. After clicking Generate, we can also monitor the logs in the SSH window to see what's happening during the process. I'm using just one step for this first request because it needs to download MiniMax H3 and Qwen 3.627b for prompt enhancement, as well as load the models into memory. The output obviously won't look good with just one step, but the goal here is simply to get everything downloaded and loaded. And as you can see, the model is now configured successfully, the request is processing, and it looks like the generation is complete and the result is loading into the interface. With just one inference step, the output is pretty bad, but that's expected. Now, let's test it properly. I'll use a different prompt to create a cinematic cyberpunk-style city video and increase the inference steps to 10 for better quality. Everything else looks good, so I'll just press Generate. It'll start processing, and we can see it working through each step, so this will take some time. And it's done. The video is now loading into the interface. Let's open it in full screen. And as you can see, it's looking really good. And here's another demo I created at 780p. It took slightly longer to generate compared to 480p, but the higher resolution gives us noticeably better quality. So that's the whole process of running MiniMax H3 locally on a cloud GPU. You can also use acceleration LoRa's like the Turbo LoRa, which can make the 10-step quality possible in just 4 steps. I couldn't test it because I ran out of credits. The setup for running MiniMax H3 locally is a bit complicated, and generation can take around 20 to 30 minutes per video. But with a good GPU at a cheap price, self-hosting can potentially be cheaper than the API. I'll also put the link to all the scripts and setup documents in the description, so you can follow the same steps. And if I experiment with it more, I'll definitely make another video about it. And for more AI-related videos, check out my channel.